Hello. So today I'm going to talk about the bending of light in the PHET simulation lab. So how to work on the lab. So before I get to the lab, let me go over some of the concept. So this is the, so we can check reflection and refraction of light. So let me talk about the law of reflection first. Law of reflection is when the light incident on the surface and then it gets reflected. So this line here in this picture is called the incident ray, and this line is called the reflected ray, and this perpendicular line on the surface is called normal. And the angle of incident ray with the normal is called the incident angle. Like this, theta1 is the incident angle, and then the angle of reflected ray with the normal is called the reflected the angle of reflection, that's theta 2. So the law of reflection says that the angle of incidence is always equal to the angle of reflection. And then the another law, the another statement of the law is the incident ray, reflected ray, and the normal all lie in the same plane. In this plane of paper, incident ray and reflected ray and the normal all lie in the same plane. So that is the reflection, law of reflection of light. So what about law of refraction of light? So to study the law of refraction of light, let's discuss about the index of refraction first. The index of refraction is defined as the ratio of the speed of light in a vacuum and the speed of light in that medium. So when the light moves in a vacuum, its speed is 300,000 kilometer per second. So it's or 3 times 10 to the 8 meter per second. But when it passes through other medium, it slows down. So the index of refraction of that medium would be depend on how much light slows down. So for example, in the water, so the index of refraction is 1.33. For the air, light doesn't slow down much, a very tiny, negligible amount. So it is about the same. So n equals to 1. For the glass, n is 1.5, and there are different type of glass have different index of refraction. So what is the law? The law, it is called the Snell's law of refraction. So n1, which is the index of refraction I talk about, times theta1 of the medium one, where the light is coming from, should be equal to the n2 of the medium 2 times the sine times theta 2. Sines of theta 2 of the sine angle. So that this theta 2 is the angle of refraction. This is right here. This is the normal line. And this angle theta 1 is angle of incidence. So n1 is index of refraction of the first medium. In this case, it's the air, so it's n1 going to be 1. Theta 1 is the angle of incidence, whatever the angle here. N2 is index of refraction of the second medium. This, in this case, water, that would be 1.33. And theta 2 would be the angle of refraction. That's how these angles change accordingly. So if you are looking for the angle of refraction, which is theta 2, you want to solve theta 2, so you need to divide n2 on both sides, and then sine theta 2 would be this n1 over n2 times sine theta 1, and then you are solving for theta 2, then it's going to be sine inverse n1 over n2 times sine theta 1. So um, that's the angle of diffraction. So which is let me show you in the lab here. So we have so you can see that theta 2 equals to sine inverse n1 over n2 times sine theta 1. Okay, so let me get back to here again. So there is another thing we're going to discuss in this lab is the critical angle. Critical angle is defined as like when light passes from denser medium, that means the index of refraction is a little higher than the other one, to a rare medium means the lower than the other one. Light bends away from the normal. So what it is saying is like when it is going from light passing from the air to water, it bends towards the normal. But when light passes from water to air, which is this is dense and this is rare medium, the light uh, bends away from the normal. So that's the rule. And then same thing we are discussing here. So light bends away from the normal. When the angle of refraction is 90, the light passes through the boundary. And the angle of incidence in this condition is called the critical angle. And when the angle of incidence is further increased than the critical angle, all the rays of light reflect to the same medium. This phenomenon is called the total internal reflection. So we use this phenomenon total internal reflection in the internet. So we have the high speed internet because of that. So some people, as in the doctors, also use the endoscopy using this total internal reflection. So they send the light from the mouth, and then they look into the stomach. The light passes. The material they use is such that the total internal reflection occurs, and then the doctors can see inside. So here is the normal case, glass, water, air, and then light passes from glass to air. This is denser medium to rare medium. So light passes away from the normal. But when you increase this angle, then then it's going to increase, and then at certain condition, it's going to be 90 degrees. Theta 2 is 90. Then theta c is, this is called the critical angle. If you increase the angle further, then it's going to reflect back to the same medium. In this case, light passes from glass and reflect back to the glass. So all the lights, no lights will pass to the air. So this is again the same condition, Snell's law, n1 sine theta 1 equals to n2 sine theta 2. And then if you are looking for theta 1, then you divide n1 on both sides. Sine theta 1 would be this, n2 over n1 sine theta 2 of the inverse of the sine. And then in the critical condition, that the theta 2 would be, critical angle would be, the theta 2 is 90. So when you plug sine 90, it's a 1. So theta c equals to theta critical would be sine inverse n2 over n1. So another thing that we're gonna check is the dispersion in the prism that in this lab. So Snell's law indicates that the light of different wavelengths, light have different wavelength. For example, the blue light has a different wavelength than the red light, and then violet one. So green light has different wavelength as well. So each different color of light has different wavelength and the frequency as well. So the Snell's law indicates that the light of different wavelength is bent at different angles when an incident on a material, like refracting material. So when a white ray of light passes through a prism, the ray of different colors get separated and the rainbow is seen. The phenomenon is of the separation of rays of different color of light is called the dispersion. So if you pass a red light color, then it doesn't get split into the different color because it's just a red. It's a one single wavelength. But if you pass the white light, then it has multiple, all 7 different color of light combined. So they split into the different color. So that kind of thing you will be observing in these lab activities. So now let me show you like how actually you do this lab. So let me go back here. This is our bending of light labs. Let me show up another this lab also here. Our lab manual. So here you are asked to draw the picture like it's the first thing is the reflection of light. So what you're going to do is just you turn on the light, and then this is the incident ray, this is reflected ray, and this is refracted ray. Right now we don't worry about refraction, just the reflection. So you can just bring the protector, and then you measure the angle. This is angle of incidence, and this is angle of reflections, and you're going to check whether they are equal or not, is stated by the law of the reflection of light. So here you decide this theta 1 in here, and this is theta 2 here, and then predicted theta 2 what would be, and then an observed theta 2 what would be in the comments. So you're going to do 5 different ways at times, 5 different trials, like changing the angle, and then you see the different angle of incidence would give the different angle of reflection and so on. This is the first part, and then you're going to draw here what you see in here at least 2 different times. So other one would be the restudy of law of refraction of light. So here you're going to predict using this equation as I saw you before. For example, let's say this is air, this is water. So here, let's say I have the angle of incidence 30, and then I want to predict the angle of refraction this. So how do you predict? You have to use the equation. So this is sine inverse. So you go to the function. I use Desmos calculator. So sine inverse. N1 is air. So I'm gonna have to use 1 divide by, and then 1.3. That's the water. And then I have to use sine of the incident angle. I did 30 degree. Then I'm gonna predict how much I expect. So I expect the 22.6 degree in the refraction angle of refraction. Let's check if that's the case. So it looks like that's very close enough. So, and then you're gonna put theta 1 is 30, and then predicted angle was we just got in the calculator. This is the predicted angle. Go here, and then actually you actually you check this angle, and then measure this angle using protractor, and then go here. So you repeat that 5 different times. For this one, air to water, and then you have to repeat the same experiment, air to glass. You can change, this is glass, and then the angle would change and so on. So, similarly, there is the critical angle. You need to observe also one situation. So that's the critical angle, glass water interface. That means you will be the top material should be glass, and then bottom material should be air. It has to, that's how the critical angle is done. So the glass to air, and then so when you predict the critical angle and the following condition, and check the predicted angle using the simulation, make sure to provide the necessary screenshot here. So you need to do the screenshot as well. So glass water interference, rays passes from glass to water. Let's put the glass, and this is the water. So now, so here, this is this angle is not critical angle, because the refraction angle of refraction is not 90. You're going to slowly increase and then make this angle 90. And in that condition, what is the angle of incidence that you are interested to check? So that is the critical angle phenomenon. So another one would be glass air interface. So the glass, and then you're going to change to air. And then another one would be the water air interface. So in the 3 interface, you're going to find out the critical angle, and then you're going to put on the table. So the other thing after that, so you can observe the prism here. You turn on the light. If it is a red light, then you can see you didn't even see the split of the color. But if you change to white, then you're gonna see something that you want to observe, and then you can discuss about what you observe in the, and then write down on the worksheet. So let me know if you have any questions. Thank you for watching.